look, personally, as a shopper, I get pretty frustrated when I have to deal with, null search results or not finding things I want or having things that I'm looking for buried on like page 6 or 7 of
Right.
a result list and I have to click one thing at a time. You waste a lot of time,
Yeah.
Yeah.
So to me, as a shopper, and I'm really glad to be doing this, which is I'm building technology that makes my time and saves more of my own time when I'm looking for things that I need.
Hello, everyone. This is the Commerce Experience Podcast. As a show, we're here to give e-commerce professionals the tools and insights to thrive in this quickly evolving space. I'm your host, Elena and I'm joined by my new co-host, Roxy Cows. And today we're fortunate enough to sit down with Xun Wang, CTO at Bloomreach. Now, he's got impressive runs at both NVIDIA and Medallia, and he brings a wealth of expertise in artificial intelligence to this week's episode, which I'm very excited about.
And together we'll discuss the transformative power of AI in e-commerce, how it's being integrated into tech stacks to unlock a layered personalization approach, plus some exciting developments about what Bloomreach is building with NVIDIA and much more. We have a lot to talk about, Elena and Xun, so let's dive in.
I'm so excited about this. Xun, welcome to the show.
Thank you. Excited to be here.
Well, I really want to kick us off with having you start to share about what you're seeing around AI being integrated into the e-commerce tech stack today. Now, you have a unique experience, so I'm excited to hear what you have to say. But what innovative search applications or trends should the e-commerce professionals be aware of that might not be on their radar just yet?
Yeah, so I think if we look at where we are with this wave of AI advancements and what the industry broadly calls generative AI, we see a lot of flashy things that is coming out. For example, we first saw ChatGPT, which is a very conversational experience with general knowledge, having this tutor my kids on like, their homework, things like that. And we saw, images being generated, which are, fairly amazing. We saw now music being generated. So there's a lot of just the idea of generating new content that is very much, we're aware of as a civilization and as an industry. One of the areas that may not be on people's radar is that the underlying technology is not just unlocking the ability to generate new content, but fundamentally, it is the ability to understand human language in a very sophisticated way that has never been unlocked before. And one of the things that how this applies to e-commerce domain is the ability to leverage that understanding of the human language to just make a lot of invisible things better. So when I talk about invisible things, what I mean here in one area is with respect to search. So how it applies to search is that because search is a very human language to computation, information retrieval type system. That's how I think about it. I think about it as in you have something in your mind that you are looking for or that you need. And essentially what you're doing is you're translating that into a intermediate format, and that is human language, right? So it's human brain compressed into human language, and then communicating that to another system. And that system now is very advanced. It has a lot of computational power, has a lot of memory, has a lot of catalog data. And that translation into the computer system requires this intermediate format that is the human language. It could be English, it could be any other language out there, right? So the unlock here, and we call this not just generative AI, but sort of one level lower than that, we call this large language models. And the ability is for large language models to be able to do that translation better so that it can now interpret what has been said by you, translating what's idea and intention in your mind into something that it can go and help you retrieve the information of. So essentially what I'm saying here is that this generative AI technology is unlocking the ability for understanding of search and information retrieval to be a lot more advanced, so that invisibly what you'll see is your results from commerce searches, your intention to go and find a particular product that you may need, all of that will just get better. Just get like 20, 30%. You might have spent 2 or 3 minutes finding things before. Now you'll find it in 20 or 30 seconds. Those are what I mean, the invisible things that this technology has unlocked for us that, folks may not be aware of because they focus mostly on the generative aspect of it.
Love it. And even being on this side and knowing all the advancements in AI, I still use it for I got 5 things in my refrigerator. Can you spit out a meal plan for me? And over the past year, my team has witnessed the improvements of e-commerce search with large language models from a front row seat. But some of our listeners might not be fully aware of the technicalities that go into these improvements. Xun, can you explain the basics of how search recall is working with LLMs?
Yeah, so just to back up a bit, I'll explain about what traditional search recall is like before we talk about how it's made better with large language models, how that's unlocked with large language models. Traditional natural language processing is what I would consider a heuristic approach, meaning that what you essentially do is you code a lot of rules into what we consider an algorithm. Some rules could be very basic. For example, if you put in a search term like dress shirt, right? A rule that we take there is usually the second word in that term we think is the category. The program is all about if statements and loops. If statements and loops, when you put it into a computational machine, it builds the foundation of logic. So, how do you, introduce logic to interpreting what dress shirt means, right? So, what we do is, you bake in some rules. You go, if the second word is something, then most likely that word represents the category of what you are looking to search for, right? So in this case, in the word, dress shirt, you say, well, the second word is the category, so it's not the first word, dress. So you're like, okay, well, therefore it's not a dress. A dress shirt is not a dress because
Right.
the second word in the English language is typically category. So it's actually a shirt, right? So that's how, in a very basic way, we are able to go and figure out what is a dress shirt versus what is a shirt dress. Just like a simple rule that says, hey, it's the second word, right? Now, as you can imagine, that might work for 80, 90% of use cases, but language is very sophisticated. And the English language is an amalgamation of actually a whole bunch of different languages. There's Spanish words in English. There's like all of these words and terms introduced in language. In fact, I've read that actually English language is the most complex language in the world.
Mm-hmm.
And you might not think that because as a basic native speaker of English, it's very simple to use it. But if you think about all of the exceptions that have been introduced into the English language, right, it comes from all cultures because it's such a wide language. It's being used all over the place. New words are being added even every single year. A ton of new words, new terms are added into the language. This makes it a very complex language. So coming back to why heuristic rules are not always best is that although this can work for 80% of the cases, for another percent of the corner cases, the rules that you bake in may not apply appropriately. And then when you apply the same rule to those things, you end up with a bunch of mistakes and errors, things that you or were intending, but the computer system doesn't understand. Okay, so that's kind of how existing heuristic natural language processing worked before the era of large language models. Right now, what has large language models been able to unlock for us? Right now, large language models does this in a very interesting way. Essentially, instead of baking in hard logic and rules, language models are built on top of neural networks. And neural networks kind of works in the same way our brain works. So when you think about how do we learn language, we don't think of, well, these things are a bunch of if statements inside our minds. It's, you get this input in your neurons and things, and then like you get this like answer, right? That's exactly how large language models work.
Right.
The neural network represent human neurons. You give it a set of input. In this case, let's give it, dress shirt. And you give it dress shirt. Now, the neurons in themselves are basically trained on a whole bunch of language examples. It's, read the English dictionary, read a whole bunch of articles. It knows about all of these different language variables and different terms and different exceptions. And at the end of the day, it spits out an answer, and then the answer is likely what you're looking for. Now, the way that I think about it is that what it has done is it's made millions of if statements, except it's no longer coded as if statements. You don't need humans to write if this is the second word, then it's shirt, or else here's an exception. If the word is a different word, that is one of the exceptions. Don't use the second word, use the first word. You're no longer relying on humans to program that. Because honestly, if we can sit down and program like 100,000 or a million of these exceptions in a giant dictionary, you can do that, but like no human is going to do that, right? So the language model basically does that for us now, right? It's kind of the encapsulation of all of those if statements and logic in a large neural network. And then what it spits out is the final correct answer you want, that this thing is actually a shirt and not a dress, right? But it's now able to do this to cover 99.9% of all of the cases, all of the exceptions, all of the things that you could have said in the human language. Essentially, it is able to narrow down on the intention and the relevance at a much higher degree than what we could by humans writing a simple heuristic algorithm to try to and divine that. So that's fundamentally, how, at least at a concept level, how language models are, unlocking this capability for this technology area.
Absolutely. It almost feels like magic.
I know, like that seems like it could get out of hand real quick. But like the fact that we have this technology now to make it that much easier, I'm like mind blown.
So, Xun, could let's go down a rabbit hole here and talk about hybrid search in particular. At its simplest, hybrid search is described as both classical lexical matching combined with vector and embedding models. Some say it's the holy grail of precision and recall. What are your thoughts here?
Well, since we're diving down deeply into how this stuff works, let me try to tie this together. So there's two factors here. One is how do we use large language models itself? Like what do I describe? What is the magic there that you're able to somehow come up with the right understanding what a dress shirt is? And the second thing is how do we combine that, and why did we decide to go the hybrid route versus going one way or the other, right? Now, start off with the first thing. When I said about the understanding of the dress shirt, how does a computer system understand what a dress shirt is? Well, fundamentally, understanding is not a useful output. It's a good way to describe the concept, but ultimately, what we want as humans when we interact with the computer system is we want the computer system to do something for us. We want some output of information, right? In the generative AI sort of classical world of ChatGPT, the output is essentially the responses back based on your prompt. We call that prompt completion, right? Now, in this case, when we apply it to e-commerce and discovery and search, the output that we want back is not a sentence about how dress shirts are awesome or anything like that. Instead, what we want is we want a list of products, right? Essentially, what we're trying to do in search is retrieve information on products in the product catalog. At least in this use case, I can talk a little bit more in a later session about what are the exciting new things that are coming up. But at least in one use case, we just want to search a large corpus of 1 million products and find out from there which ones are actually dress shirts and get a list of them out to us. And then for the human to see that list, pick through it, and then essentially purchase that thing. Right? So really that area of the matching between the query term and the recall set is what we're talking about in what we mean by implementing this understanding of this LLM technology. How we do that is essentially we convert both the query from the shopper, the user, right? So in this case, it's the dress shirt, that English text term, okay? And what we do is we convert that into what we call an embedding, okay? And I'll explain a little bit what that is, but I'll just explain the other side of that. Now, on the other side of that is the million products in the product catalog. Now, the million products in the product catalogs also has English language words, or whatever language, if we're trying to do different languages, right? Now, those are in the form of things like the title and the description, right? Those are two basic things. There's a whole bunch of other things like attributes and price and all of those other things as part of the product catalog. Let's take a simple example with just the title and description. Those things are described in English. So the task that the computer system must do is, how do we use these large language model technologies to find the relationship between the query English text versus the title and description of each individual product catalog item, and then make the best match possible. That's essentially what the doing a search recall is doing, right? Now, how large language models are implemented here is, like I said, we take the input query text and also product text in the catalog, and we convert them in what we call an embedding. What an embedding is a numerical representation of the text that you put in, or the text from the product catalog, right? And this numerical representation is a multi-dimensional set of parameters, and you can select which one, how big it goes. We use 768. So 768 means that there's 768 numbers that now represent the term that you put in, dress shirt. So you can imagine you basically put in dress shirt into the large language model, and out comes a set of 768 numbers. And they're numbers that you don't even know what these numbers mean really, in the exact way. But what they represent is the knowledge of this civilization, the knowledge of language as it relates to the term dress shirt, right? So it represents, one of the numbers will represent, well, a dress shirt is probably a piece of clothing, and that number is, I'll just make it up, it's maybe a number 642, and that 642 position is number 0.6532, and that number is sort of the correlation between what you wrote in and the idea of clothing. Okay, or the idea of a formal clothing versus a casual clothing. A dress shirt is more of a formal thing, not a casual thing, right? Or it's long sleeve or short sleeve. All of those concepts or those relationships are now represented as some number in this 768 dimensions, right? So what the LLM has done is, because it has encapsulated human language and the concepts of our civilization through its understanding of all of the internet and all of the training data, it's able to take your single term dress shirt and add to it all of that knowledge and represent it in a series of numbers. And that's how we finally return, using vector LLM technologies, the result set. This is how the machine actually uses this technology to actually figure out which of the products to return that matches what your intention is when you put in the query.
Well, I have a question here, because I think the rule of thumb in, when you're working with large language models like ChatGPT, they say that the more specific you are, the better output you're going to get. But I find that when you're very specific, when you're searching for something online, there's a miss. Like sometimes it's not able to compute. And so that's why, and just to clarify, because I maybe break it down for me, but that's why technology like this is like allowing you to be more specific, because then you can get exactly what you want. Correct?
That's exactly right. Yeah. So in the search world, we call that long tail search queries.
Right.
And the reason why long tail search queries has traditionally not worked well is because, again, it goes back to our heuristic algorithm, right? Our heuristic algorithm looks at a long string of text. Let's say, I have a lot of problems with fixing things around the house. So I'm like, the thing that I need to fix the door handle because the door handle is broken. I have no idea what to call that thing because I've never bought it before. So I just type in like a problem, and it's very rare that I get an answer for that, because like the computer system just like, well, I don't know what that means. All I can do is just take words and match it with other words, essentially. And that's the old technology, right? But what essentially large language models have unlocked for us is it's actually able to understand what you have said, because other people have said something similar. There probably was another, thousands of people have the exact same problem as I did, and they described it as this thing that fixed the doorknob,
Yeah.
right? And it related it to this product. So, or related to the concepts around this product. So, what large language models are able to do is it doesn't just try to use an algorithm to say, hey, ignore this word, use that word, drop this word, make this simpler, right? It's able to take the entire term of what you put it through this language model, and out comes a huge set of variables and numbers that roughly match what your intention is of what you're looking for, plus all the knowledge it learned from other people on the internet saying about stuff like this, right? So if it knows that other people, figured out that what you're looking for is like a lock or something, like a deadbolt lock, right? Then it will know that the deadbolt lock concept, and what is it? It's a lock, it's metal, it can be bought at a hardware store. All of these ideas and concepts related to this thing is most likely related to the words that you put into the system. Mm-hmm. And because it has that knowledge and is able to make that relationship, then it's able to take a product that has that description and also translate it into a number that roughly matches what your number is saying. So you're absolutely right. This technology has basically unlocked the ability for you to be able to say whatever you want. And as long as you're not saying something completely random and something that other people have said, and it's part of the training of the language model will do a much, much better job than helping you find that piece of information somewhere else that's correlated to it.
That's interesting. And I know you were going to go into the hybrid piece, but did we hit on that already, or is there more to that? Because I know we did say we were going to go down a rabbit hole, so here we are.
There's definitely more to that. And, what we found is that when you apply this way of doing vector searches and using embedding models and do this sort of matching between the query term and the product corpus, right, that solves a lot of these problems. Like, we just described these long tail queries, things that, you don't know, even simple things like dress shirts, right? So what we found is that if you use keyword matching, that keyword matching is a little bit more precise. So we think of it now as two separate signals. We have one, which is the vector signal, and then we have the other, which is the text relevance signal, which is our classical lexical matching, right? And it is the case that when we combine these things together, and this is frankly just pure data science. It's not something that we can know beforehand. This has to do with discovering what these things can do. That's the difference between data science and engineering. Engineering is like you intend to build something and then you go build it and it manifests. Data science is you have no idea what's going on. You just have to run a bunch of experiments, and then from those experiments you realize some insight, right? Mm-hmm. And this is where we use our data science capabilities, did a whole bunch of experiments across different catalogs, different query terms, looked at the results of those things, and then we found that the mixing of these two signals ultimately, at least today, gets us the best result in terms of being relevant and being precise, but also understanding these long terms and and creating automatic synonyms and all of these things, or understanding synonymous things, right? So that's where the hybrid part comes in. Yep. It's really through the experimentation and data science that we found that this is really the best optimal solution at this time. Now, that may not mean that this will always be the solution in the future. As you all know, the technology is advancing very, very quickly, right? Mm-hmm. So in some future state, as these large language model gets better and get more refined, that threshold may change. Today, maybe that signal for vector is worth this much and the text-based signal is worth this much. But as vector and embedding and language model technology gets better and better, and it gets more tuned towards particular use cases, then we have the ability to go and change the signal strength of this differently. At some point, maybe far in the future, we don't even need the text lexical matching at all. But at least at this time, we found that the state of the art, the best, is when you combine these technologies together. Much like you can take an analogy to automobiles and cars. You have your fully electric cars, you have your hybrid cars, and you have your gas engine cars with some
Hmm.
optimizations, like cars today that stall for a few seconds, at the stoplight, right? All those things are similarly, trying to solve a problem, but in different ways. You can go all in, you can go in the middle, and personally, I also have a hybrid vehicle as well, and hybrid vehicles are actually the most complicated engineering vehicles. It's like it has a whole electric car in there, but also has
Yeah,
a gas car, right? So, similarly, that's the technology we built. It has all of the new technology with LLMs and embeddings and all of these things, and it has all the latest and greatest let's go technologies that we've always had. It's the combination of these two things. And similarly to electric vehicle, you get the benefit of both worlds. You get to
Yeah.
ride around, in the city most of the time on electric, and you get to go long trips and not have to worry about it. And
right.
that's what we have here, essentially, with our hybrid search. It's the best of both worlds.
I love the best of both
That's a great
worlds.
analogy.
That's a great analogy. I think that'll be perfect for our listeners. And the fact that we've been able to go this deep, I feel like we've never gone this deep before on the podcast, but I think that's the benefit of having you both on because then you're obviously working on the technical side and this stuff. I feel like I just went to class and I'm like writing all of this down, but I really do want to flip it on its head too, because I think Roxy, your work is all about measuring the performance of our personalized search capabilities and over the last 5 years. So I guess with the incredible advancements of AI that Xun just began, telling us a little bit more about it, our product is evolving. Like the amount of,
Yeah.
it's moving so fast. So I'm curious to hear what key metrics or examples of lift have you seen while using this hybrid technology that he's described?
Yeah, absolutely. So my team is an integral part of our search optimization strategy and measurement arm of the business. So we're working directly with our clients to drive their commerce and product discovery search experience. From a search perspective, in measuring the impact of hybrid search versus text match versus like how your experience is performing overall, the primary KPI is always revenue. So we're looking at RPV, for example. From a business perspective, they're asking themselves, are we making more money than we were before? But
Right.
there are also other critical metrics because if relevance is improving, because now we have this experience that is pulling in the most relevant results that we can find, they also want to see other things improve. Like, are we seeing a higher product view rate because relevance is better? Are we seeing a lower bounce rate because now people are able to find what they're looking for better? And then are we seeing a lift in add to cart? So once relevant better, are all of these other KPIs following suit? And we've kicked off a number of A/B tests with clients to really validate their personalization strategy and showcase the impact of hybrid search. So that optimizations, that really looking at that experience to see how it's actually improving the customer journey is always ongoing, and it's really exciting to see how hybrid search is changing the game for search.
I'd love to hear how you both believe that all of the advancements that we've made so far or any of the new features will really make a difference. I mean, Zan, are you seeing that that's top of mind in terms of what the customer needs? What are your thoughts around that?
Yeah, I mean, absolutely. Look, I conduct e-commerce for 99% of my purchases. I'm a big fan of e-commerce. That's why I'm at Bloomreach. And look, personally, as a shopper, I get pretty frustrated when I have to deal with null search results or not finding things I want or having things that I'm looking for buried on like page 6 or 7 of
Right.
a result list, and I have to click one thing at a time. You waste a lot of time. you
Yeah.
know.
Yeah.
So to me, as a shopper, and I'm really glad to be doing this, which is I'm building technology that makes my time and saves more of my own time when I'm looking for things that I need. So ultimately, I think that's the difference that we're making to shoppers like myself. And the value that we're bringing to our customers, who are brands and retailers and so forth, are when shoppers are doing things more quickly and ultimately finding what they want or need, then that increases their loyalty to the brand. and
Yeah.
that increases, the click-through rates. And when you have loyalty and when you have just a much better experience than you had before, then that is the best for everybody. It's both good for the shopper and good for the brands. I can't tell you how many times, I had to search exactly as you said. You put a long search term, and literally I've put terms like this before, like, find me the thing that fixed this thing that does that. I just couldn't find it. And I would spend hours, on Google, and then I would look at YouTube and I watch YouTube videos of people fixing things. And then in the middle of that YouTube video at time, 14 minutes, somebody says, "Oh, you need to search for this particular product." And I go, "Oh, okay, I need that exact term." And if I plug in that exact term, I can find it. How many hours did I spend, going through that process? A lot, Now you
Totally.
don't have to spend that time anymore, because that's the power of these large language models.
Absolutely. And I'm the same way. I mean, as a consumer, because it's always great in this work to put yourself in the mindset of the customer, but we're all customers. We're shopping online. I buy everything online. I've bought furniture online, never seen it before, but I just trust the experience and that it's going to it's going to be exactly what I want. But I think there's outside of me being a customer and being impatient, and I need to, if I'm searching for something, I want to find it immediately. I think the work that we're doing is it's improving efficiency for merchants. So instead of spending a lot of time manually merchandising, reducing noise, and trying to boost Berry, try to figure out like how your shoppers might search before a product launch drops, you now have these advancements in AI and product discovery that are helping you to do that work. So then you can focus on more strategic initiatives. And I think that is so important. So we're making our merchants and our practitioners' life easier and their job easier by these advancements. And I think too, it's really driving a better shopping experience for customers. I always joke that I think I'm good at searching Google. Like I know how to formulate a query to get what I want, uh, being very specific with the right keywords. But shoppers, they don't have that level of knowledge, and they shouldn't have that level of knowledge. So when you're searching for something, regardless of how you choose to search, you should be able to see the most relevant results that you're shopping for. You should be delighted with other things that you weren't searching for, but you might want to buy, hashtag impulse purchases. And
Yep.
then also just streamlining that experience from initial consideration to discovery and on to checkout. And truly, at its core, all the advancements in technology and the work we're doing is creating a better shopping experience.
Totally. And your website is where you want people to find your product ultimately. So you can capture all of that data and you want their experience. I mean, once you get to Google and you find the website and it shows exactly what you want to see, it's like that's where you want to keep them and you want to give them that good experience so they keep coming back. So I think both of y'all's perspectives have been fabulous on this because I do think that seeing both sides next to each other is really helpful for the listener.
Absolutely. And then getting back to personalization, I've been in this space for a while, and personalization as an approach is something that's eluded merchants for many years. In part, I see it being because of this obsession with one to one personalization, when realistically, personalization should be multifaceted. It should be a multifaceted approach. Zan, could you speak to this?
Yeah. So, when we think about what we're doing with personalization, in search specifically, right? We're talking about really personalization in search. There's a lot of different other types of personalization as well. For example, recommendations
Hmm.
and the sort of just for you type of capabilities, or what I would call the YouTube sort of recommendations or TikTok recommendations. That's a little bit different than personalization for search, right? In the other type, which we also have as well, you're not. There's not a strong signal of intent. There's only a signal of what you have previously viewed. So if you want to show me something that I might like based on my previous viewing habits, right? That is a different problem than if you need to mix that with a clear intent, right? So that's why it's now a much challenging thing to solve for if you need to merge personalization in with search, right? So what we've seen with search in terms of the signal strength, if I were to put it into three broad categories of total strength, the highest strength that you have is intent, right?
Mm-hmm.
And that is what really built the whole entire Google business. Google is $1 trillion company because of this one reason. The fact that you are telling the computer system what your intention is, it's already on your mind, and you're just translating it into, again, English words so that the computer system can understand that, right? That is the highest signal that you have to be aware of. So if I'm searching for a jacket, right, you know that my intention is something related to a jacket. So you better show me jackets, not something else.
Yeah.
It doesn't matter what my past preferences are. Show me jackets. You know what I'm saying? So that's like the strongest signal, right? The second strongest signal, and this is part of our system as well, is the performance of
Mm-hmm.
products. Out
Right.
of 1,000 jackets, what are the jackets that a lot of other people purchased? I
Mm.
think 80% of the time when I go shop personally, I finally end up buying the bestseller. And it
Right.
just like a group, thing. It's like, oh, if other people bought it, that's good. Most likely I'll like it. So I should buy this choice or the bestseller thing or whatever. Right. So out of the group of 1,000 jackets, I'll buy like the bestseller jackets 80% of the time. Right. Unless I'm looking for something very specific.
Yeah.
So that's the second highest signal. Right. The third signal I think that is important is the personalization signal. And that
Mm-hmm.
is, based on my previous interactions and what you know about me, what kind of jacket should I want to get? So one of the brands that I love is, for example, Under Armour, right?
Mm-hmm.
So I buy a lot of Under Armour stuff. So if I search for a jacket, then and all I told you is the jacket, not a jacket, a Ralph Lauren jacket. If I put in a Ralph Lauren jacket, you better show me Ralph Lauren jackets because again, the intention signal is the strongest. But if I just
Right.
type in a generic term jacket, then ideally I want to see something that I might have based on my previous purchase history be relevant to me. How do I know that difference? A very simple algorithm, all it would do is just always apply the brand for Under Armour jackets to jackets, and it will say, well, for pants, then I'll still apply Under Armour for joggers and pants, right? But that might be a mistake because perhaps for joggers and pants, there's enough data to suggest that I prefer Adidas joggers and
Mm-hmm.
pants, right? So again, we have this problem of there's many exceptions. There's many
Right.
different ways we as humans have preference. There is a matrix in our minds of what should be preferred for brand, for color, for things, and it's a multi-dimensional matrix, right? The question is, how do you have a computer system be sophisticated enough to try to divine and fill in that multi-dimensional matrix with only small pieces of sparse data? That's the challenge when we talk about multifaceted personalization. How to make sure that we apply the right attributes and the right facets there's many connections in our own neural networks to particular products. And that's what we're building with Personalization 2.0. Personalization 2.0 takes into account this sophistication. It also uses some of the newer machine learning algorithms, it uses language models in a way so that we can build using aggregate knowledge these types of relationships between what facets are generally attributed to what, if people generally like colors in fashion, that might be associated with different fashion products, but it's not associated with buying laptops. Just because you like a red jacket doesn't necessarily mean you like a red laptop, right?
Right.
So we use the aggregate information of the world to build this clustering of which facets should belong to what, and then we have, in this case, more heuristic algorithms to figure out, well, if you have an intention that you specify Ralph Lauren, then you better not show me, Under Armour jackets if you
Right.
have that intent.
I love it when a brand is telling me products that they think I might like too, because I'm like, "Oh yeah, great. Don't make me think." Roxy, we've talked about that before. I'm like,
Yes,
"Yeah, I think I
exactly.
might like that. Thank you so much for that recommendation based on my previous purchases."
So before we wrap up, Zun, I want to talk about how Bloomreach is collaborating with NVIDIA, a company you worked for prior to Bloomreach, on some exciting new developments. Can you share more about this partnership and what we're building together?
Well, as most of you know, NVIDIA is a huge name in the AI industry at this point. And, having many connections at NVIDIA, uh, for us at Bloomreach, we are able to go and leverage the best and greatest technologies and support from NVIDIA. NVIDIA is going to be a co-sponsor for our upcoming Edge event. And we are working every week with them to go and introduce AI technologies to our system, the latest and greatest AI technologies. Now, one partnership I'll talk to you about. We're doing a bunch of things in a lot of areas, but one thing that is pertinent to this discussion is our search innovation. Right? And what we know right now is that when we go and fine tune these models, that the ability for these models to perform better for our specific domain gets better as we fine tune them. Training these language models essentially means you teach it things, you give it data, you put data and you put it into a training algorithm, and then it makes the model better. Well, ultimately, what is the hardware that you use for training these days? Well, it's NVIDIA GPUs. So NVIDIA has spent a ton of, like, just billions of dollars refining their training capabilities on their GPUs, and also now their serving capabilities with NVIDIA NIMs. So what we're collaborating with NVIDIA on is making use of, number one, the NIMs technology, which is the software that we use for training, for delivering on top of GPUs, and it's highly optimized. It'll increase our performance by an order of magnitude, and also reduce our cost as well. So it's going to give us the ability to better tune our models, give you more relative results, give our results faster, and as a benefit, also cause less cycles and less electricity burn for this entire world. So it's the benefit of all of those things on the technology front that makes search inherently better for us.
I am fascinated by this topic, Zun. This is amazing. And it's been fun to chat with you about the technical side of AI and personalization. Thank you so much for coming on the show. Of course, Roxy, it's always fun to have you here. I'm thrilled to have you be a co host moving forward on upcoming episodes. So stay tuned for more from us. And thank you again for tuning in, everybody. If you're enjoying our recent content, subscribe to our bi weekly episode drops. And don't forget to rate us 5 stars on whatever streaming platform you choose. And we've got tons more content coming up. Zun mentioned the Edge Summit, so you don't have to be there live to catch all of the good insights. So we'll share that in the link description below.
And that's right. We'll be live streaming the keynotes free of charge from the Edge Summit. By registering, you're unlocking our digital content library with exclusive content and conversations with our panelists after both events. Don't let distance keep you from being a part of the conversations. Register with the link in the bio.
Amazing. Thank you all, and we'll see you next time. Bye.
Thank you all.
Thank you. Bye.